Good morning, everyone. Thank you for joining our research presentation. My name is Dr. Nicholas Babatokwe Allo. I am part of the leadership team at Visual Earth, and today I will be presenting one part of the output from grant-funded research work Visual Earth has done in collaboration with the University of Texas Southwestern and the University of Texas at Dallas. This work is being undertaken on behalf of Lagos State's Ambulance Service, an arm of Lagos State's Ministry of Health. Now, let's begin by getting to know Lagos. This city is known to its traditional and elderly as Eko, and by its young, modern, and energetic as Lasgidi. To its visitors, the city is identified as a center of excellence. So now let us begin by getting to know Lagos. This city is known to its traditional and elderly as Eko, and by its young, modern, and energetic as Lasgidi. To its visitors, the city is identified as a center of excellence. Where one travels across this city, you will encounter its interesting character. You will get to experience its symbiotic and respectful balance between old and new, then dare to be made breathless by its bold and audacious traits. Get ready to stay up late because it's a city that never sleeps. It is, however, burdened with social challenges brought about by extremes of poverty, a factor that influenced our approach to the solution created as our research output. You see, these extremes of poverty make household low income. About 75% of the Nigerian population are classed as low income, making the remaining 25% middle to high income. The availability of income impacts directly the investment by mobile operators in expanding their networks and its services. So in Nigeria, you find 2G coverage by networks to be most widespread, whilst 4G offers greater connectivity is rather sparse. No wonder the levels of poverty influence the way the Nigerian two halves communicate. It also impacts their attitude to work, so much so that the low-income cohorts are willing to take greater risks to make a decent wage. Often long-distance travels are a necessity, and they will willingly risk life and limb on such trips. Sometimes they need to move large volumes of products or consumables and do without concern for their safety. Then some of them daily put themselves in harm's way, attempting to make a living in traffic, running between moving vehicles to sell items, all of which are sources of accidents on our roads in Nigeria. So let us return to Lagos. Now, the state government is going to lengths to curb and limit the source of accidents on its roads. For starters, the Lagos state government banned the commercial use of two-wheeled and three-wheeled vehicles on major and minor roads. The state also is on an aggressive infrastructure and update scheme, improving transport hubs across the state. They have also introduced new, modern, and comfortable buses across all routes in the state. The state's traffic event group, LASMA, are daily working to ease off and eliminate traffic congestion, whilst the state's emergency management team, LASIMA, remain on call 24/7. The most important is the state's first responder or ambulance service, LASAMBUS, leading the charge to save lives. Now, this context leads into our research study. In a pre-research study carried out for LASAMBUS, it was identified that the majority of emergency calls and dispatch were trauma-related. About 60% reported calls between January and July 2019 were badly handled, or at least were identified to have been badly handled. And many times, the ambulance crew were given a wrong location or address to attend. And such confusion and delays resulted in bystanders and well-meaning Lagosians transporting trauma victims to the nearest hospital. Now, such action sometimes aggravates a victim's trauma, and this prompted our need to find a way of reducing the burden of road traffic associated mortality by using mobile technology. Consequently, our research first aim, we have two aims, by the way, was to research and develop a methodology as well as technology that makes this possible. Hence, we devised the following aims and we devised the following objectives as key tasks within aim 1 for our study. The first was generating reports about an incident using unstructured supplementary service data, USSD, and also to identify the location of a caller as a proxy for the location of the reported emergency event. Next, we would explore methods of trawling through social media or posts on reported incident with the intent of collating and collecting and grouping content that will help offer context about the incident. Finally, we would attempt to compare various reporting accuracies and the improvements likely to be brought about by our work, some of which are location, timing, data records, and of the incident captured by the ambulance crew. But I should also mention that we have achieved all 3 objectives that we set out to achieve with our study. Now, in a moment, we will run an end-to-end demonstration showing the process and its output. But before we do, I would like to quickly run through each objective and some of the hard lessons learned along the way. First objective, in the mobile operator was key. However, some of the documentation, currency, the processes preferred by some of the operators posed some challenges along the way. Our learning, however, from this was to always question the update status of every integration document we get. And as a note to self, at the next iteration for this service, we will require of ourselves identifying ways of eliminating third-party requests, which we've had to use, to make this service work faster. In such a case, we'll be expunging most of the third-party services in future, as this helps us cut back on some of the service execution and response to the delivery time that we are able to achieve at the end of every single task we do. Then, for the second objective, part of the work here was done in collaboration with the University of Texas at Dallas. For the web scraping component, this proved to be a lot more straightforward, but it still had its challenges. For the web scraping component, this proved one of the challenges we had, given the map service adopted during the proximity calculation, is image-based. Now, in this case, it means we're unable to do network computations, routing between different locations. So we can only compute distance as the crow flies, which means we're computing distance in a straight line from point to another. Now, our learning and takeaway from this objective is during our next iteration, we will build in a feature layer based map service. This would enable us to interact with independent map features and apply numerous geoprocessing routines and logic that will output results to be displayed in. The last of our objective was focused on improving the accuracy and timelines of reporting. But here also we had challenges faced. The most prominent was that no internet connectivity for the device that is being used was possible outside of using Wi-Fi. This meant it was impossible to run a real-time series of updates of incidents and records, and as a result, we decided to create a data sync function for use when within Wi-Fi coverage. Now, one of the lessons that we learned as a takeaway from this to address in the next iteration is that our team will identify the ideal equipment specification, and we would also build in robust protocols that ensure persistent internet connectivity via the mobile operator SIM that we'll be using for our connection with respect to this service. Now, we'll be looking at the demo, and the demo that we'll be looking at, give me a second, let's go back here. Right, so we'll be looking at a demo, and given that we've taken a look at the objectives, I'd like to offer a live demonstration of the service. The demonstration of this service will be in 4 parts. The tasks to be carried out will be that we would look at executing the USSD service, but given that we can't see the USSD service being executed, we will see a video of the execution of the USSD service. Then the next part is we will see the location and the preliminary incident record populate onto the page after the USSD has actually been initiated local in Nigeria. And then next we will see a demonstration of the mobile app, which has been made available to the medical professionals, which would allow the ambulance crew input details of the accident after they've been notified of the accident by the crew at the command center. And then once this record has been updated within the app and they are within Wi-Fi connectivity, they can push these records to the server via a sync to the command center data, and we would then see that information as well as it populates into the database. So let's take a quick look as we move along into the mobile app. So this is what would typically happen if perchance the individual was dialing the message on the USSD. You would then be presented a menu whereby you make a selection from that menu, and on having made the selection from the menu, you would be given a message that says to you that help is on the way. And that takes us now to the next part, which is to look at the generation of the records at the back end. So if we click on this, this takes us to the page, and here we can see that a record has been generated. And if we click here, we can identify that this is where this particular incident has occurred. And having seen where the incident has occurred, and look at getting the address, and we see where the address of this incident is. And then if we identify where the nearest ambulance is, here we've done a click on that, it identifies where the nearest ambulance is. Now, if we click on this, we have some information about the ambulance, and having identified some information about the ambulance, we're able to then now go in here to identify the record with respect to the incident. And here we can then now collect this data, and we would then now move to the app session. Now, to use or to view the app, I would need to very briefly connect with one of my colleagues in Nigeria who will show us the use of the app. Right. So what I will be doing here is I'll connect with him, and in connecting with him, because I've not been able to show the app. Because so the app was meant to be on an emulator, but I've not been able to get the emulator working on my system. Now Donald will be sharing his screen to show us how. Donald will be sharing his screen in a moment to show us how he's able to then connect to take the data from the dashboard and input it into the mobile app data, and on collecting data to then update that data to the dashboard. So here we can see the dashboard has been, or the mobile app has been opened up, and in open up the mobile app, the call records will now be put into the system. Now, the last call that we've seen that we identified on the screen, the record is now being input into the system. And as the record is being input into the system, what we would then see is that the call will then update onto the mobile app. And within the mobile app, we would then now also see that he is now putting in the details with respect to the accident that has happened, which in this case we're assuming is a collapsed building. And he's then now opening this up to add the patient record. We then input the details of the patient, and in having entered the details of the patient and his location, and potentially whatever details we can get, we're then able to now go in and also look at some of the routes with respect to the patient's information. We can update this, and whatever it is that is updated in here then becomes possible to collect as much detail with respect to what's happened to each of the patients at the accident. And having done that, we're then now able to sync this data to the dashboard. Now, having done that sync to the dashboard, we would now swap back to the system and would look at the dashboard. Thanks, Donald.
Hi, Nicholas, please pay attention to the time limit, okay?
Yep. We're almost done. Now, if I quickly update the dashboard here, now we can see, let's go to the incident here. Right, so this here is the dashboard detail with respect to the collapsed building that has been updated, and you can see that the information has been put in, the details are all here, and we can see all that information. So if we quickly go back to our presentation, the detail with respect to the demo that you've seen is all available here. Now, if we quickly try to recap on what it is with respect to the demonstration, I hope you found it useful. And as a quick reminder of research outcomes, we've improved convenience and reduced the time it takes to report an incident. We've reduced the response time of first responders to incidents. We've radically increased the accuracy of incident reporting, and we've improved the efficiency in coordinating incident management. And as a result, we hope to save more lives. Now, I'll quickly touch on some of the mobile health opportunities from the view of Velasambas and the value our project offers to the state. But note that this list is not quite exhaustive. Now, I'll quickly, so first, the ambulance, first an ambulance crew review so first an ambulance crew can review the options of the hospitals they have with them, can make a selection to inform ahead which hospital they need to go to, and then also inform the hospital ahead with respect to the arrival of patients that are coming. Then there's also the prospect of electronic records being generated, which makes it possible to improve the delivery of healthcare, which is a service that is relatively required. It's quite required within Nigeria, but we don't quite have it quite yet. So this becomes a foundation to that particular service opportunity. Then it becomes possible for us to also offer this mobile service to other government agencies as well. And it also it becomes possible to explore working and enlisting private ambulances as well, who can then increase the capacity that is available. And then it becomes possible to provide also a mobile app, just per chance there's any situation whereby there's a need to give access before the connectivity with the mobile operator, enabling us to use a USSD, is possible. So we effectively are able to look at these, and these we think are some of the opportunities that our system potentially offers. And given that, do we have any questions? Thank you.
Okay. Thank you. Thank you, Nicholas. And we still have time for the questions. You can just type in the chat box. I think this is a very impressive presentation. Okay, here. Does the app assume the person sending the messages, such as the damaged buildings, that at the location, or can someone tag another location different to where they are located? And if so, is this being abused or fake reports? Can you answer this, Nicholas?
Sorry, I didn't hear the question. Can you take the question again, please?
Does the app assume that the person sending the message is at the real location of its
Right.
spatial coordinates, or
Right.
can someone tag another location while they send these messages?
Right.
If that would be some fake reports, right?
Right. Oh, right. So first and
Yeah.
foremost, it's not an app. It's unstructured supplementary service data. And then what that means is that it's real time. Now, the person would once the person generates the message is a we look at the message as a proxy for the location of where the actual incident is. So that means that if someone was to use the service and we were perchance identifying that there was no incident there, then the effort to call the person to ask if there was actually an incident would occur. However, one of the things that we know is that people in Lagos are aware not to use services and do such mischievous things because it would put lives at risk.
Okay. Any other questions? Okay, I have a quick questions. I wonder,
Sure.
can similar techniques can be applied to another scenarios, such as medical, help us to optimize the medical resources? Because we know that patients may do not have so much accessibility to the medical facilities, and they may, if with your techniques, we may report our health conditions, and you could further give us some information about this hospitals or docs or something like that?
Right. So in terms of using the system to drive medical logistics, it is possible.
Okay.
The key thing here is that for every single call that is done, we're able to identify location of the caller. And we use a GeoSMS framework that we've built. Apparently, we found that there wasn't any GeoSMS framework to do what we needed to do, so we've built one. Then, with respect to then now coordinating the logistics regarding the activity from within a hospital, it is possible to build the required services or the required tool set that then tie into the trigger that is given by the location. But the key thing is being able to identify the location, and having identified the location, to then now assign the what's called a webhook, which is the service that you need to call up to run after that particular service or that particular trigger has been initiated, to get the service itself running. So we're able to do that if a chance there was a requirement to do that for an organization, for a health agency who was looking to do such.